Let's do a couple of things. I just want to go over a couple of types of problems that you'll see on the exam that I think are probably among the more difficult problems. We can come back to the free response if you want to look at that, but your free response will look a lot like the fall 23 exam. Just the numbers will be different. It'll be laid out on the page in a very similar way. I might have a velocity versus time graph rather than a position versus time graph, but if that's the case, I'll just ask you the instantaneous acceleration and the average acceleration. It's going to be basically identical to these problems, okay? So we can come back and work those. And then also the kinematics problem is very, very, very similar to this one. I think the words are exactly the same, it's just the numbers are different, okay? So make sure you can do those without flaw and without really thinking about it. And then I want to look at a problem. Yeah, let's look at this. I mean, there are these types of, I don't like that one. I like.
On that, the response, you said if it's a different type of graph, what was the
Like if it's a velocity versus time graph, I would ask for acceleration, instantaneous acceleration and average acceleration. Because the slope of a velocity versus time graph is acceleration, right? The slope of a position versus time graph is velocity. So that's how that would change. Yeah, let's look at this one. Like, if you look on all the exams, I have a spreadsheet where I want this number of questions for this number of, this topic, and that's why all the exams look really similar, because I'm going off the same, framework for every exam. And so you'll often have questions like number 17, which sometimes students find a little difficult, right? Because you have to think about these graphs and what they represent. So let's just go through this one. This is a couple of years ago, number 17. It says, you just want to go through each statement. First, recognize that this is a position versus time graph. Did anybody catch which one this is? This is fall 22. So this is a position versus time graph, fall 22. And I want to assess each of these questions. First, the object is stationary at points B and D. Now, since it's a position versus time graph, the velocity is given by the slope of that graph. All right, so here, the slope of that graph is 0, and there the slope is 0 as well. So it is true that the object is stationary. It's stationary at those points. So that option is correct. It says it has a positive acceleration as it moves from point A to point B, so as it moves along this graph right here. Now notice what happens here in this section of the graph, that my slope goes from being, big and negative to being small and negative. Okay? So that means I have a negative velocity, and that means that it's slowing down. So since it's slowing down, the velocity and the acceleration are in opposite directions. That means I have a positive acceleration. So number 2 is also correct. Be able to do that type of maneuver in your mind where you look at it, is it speeding up or slowing down? If it's speeding up, the velocity and the acceleration are in the same direction. If it's slowing down, they're in opposite directions. So that one's correct. The speed at point C and E is the same. So here, what we're looking at is the slope of these graphs, C and E. Are the speeds the same for points C and E? Yes. So if I ask for velocity, the velocity would be different because I would have a positive velocity and I would have a negative velocity. But I'm not asking about velocity, I'm asking about the speed. And remember, the speed is the magnitude of the velocity. So what it's asking is, are the magnitudes of these slopes the same? So if this is positive 2, then this would be negative 2. And those do appear to have the same slope. So both C and E have the same speed. They're in different directions, but they have the same speed. And then the acceleration at point B is 0. Oh, I'm sorry, that should be wrong. It's not 3. So 3 is not, yes, it is correct, I'm sorry. So the speed at point C and E is the same. Now the acceleration at D is 0. What do y'all think? No, it's not 0. In fact, the acceleration here is have a negative acceleration. Now the velocity is 0 because the slope at that point of the function is flat. So the velocity is 0, but that's the case where I have an object that's going up and coming back down again. It's that point at the top where it stops and turns around and starts going the other direction. So that answer is also correct. So the acceleration at D is not correct. Sorry. Acceleration D is 0. So it should be 1, 2, and 3. Okay? Practice those. There are questions like that on every exam. So those are sometimes some of the more difficult questions. There's another question that I want to tell you. This is actually from chapter 1. I'm not going to give you the numbers, but I'm going to tell you what it looks like. I just took a picture of it. Get it right. So I'm going to give you a number in square kilometers, and I'm going to ask you to convert it to acres. Okay? And what I'm going to give you is I'm going to tell you that an acre is 66 by 660 feet. So I'll tell you this, 1 acre equals 66 times 660 feet. 66 feet by 660 feet. So I'll give you that conversion factor. And I'll ask you, I don't know, let's say that I have 12 square kilometers. How many acres is that? That'll be the question. So this is a unit analysis, or where I'm changing units from one unit to another. But I want to step through it just because it's a little more complicated than the ones we've done in the past. Is that okay? You will see this on the test tomorrow. So the first thing that I need to do is to figure out how many square feet are in an acre. So 1 acre, I gave you the dimensions for the acre. 1 acre is going to be 66 times 660, which is going to be 43,560. That's in square feet. So 1 acre is 43,560. By the way, I'll also tell you that 1 meter is equal to 3.28 feet. I give you both of these conversion factors. Now, if I want to convert that 12 kilometers squared, I say 12 kilometers squared. First thing I want to do is to convert those kilometers to meters. So I say 1 kilometer is 1,000 meters. But I have to square that unit, right, to get rid of the kilometers squared. Then I want to convert the meters to feet. So I say 1 meter is 3.28 feet. I have to square that conversion factor as well. Then I want to change my feet squared to acres. So I'll say that 1 acre is equal to 43,560 feet squared. Do I square that conversion factor? What do y'all think? Do I square it? I do not, because I would have feet squared here when I square that number, but I already have feet squared here. So I don't square that last conversion factor. And then when I get that, I get the answer, whatever that is. Now your question won't be 12 kilometers squared, then it'll be some other number. Okay? So be prepared for that. It's not difficult, but it's a little bit different than what we've done before. All right? Specific questions that you have. Do you want to look at the free response, or do you have specific multiple choice questions that you want to look at? Yeah, Maynard.
Number 9 on ball 23, the answer of 148, is there a reason that was squared, not used? The answer?
Number 9. No, it should have been. All of them should have been centimeters squared. It was just a typo. So each of these should be squared, squared, and squared. Because I'm looking for area, and so area is in centimeters squared. Typo. It's just typo. What was the right answer? C? Yeah, okay. Which is in square centimeters. That's what you want it to be. Because it's area, which is in square centimeters. Is that clear? And also, so this should have been not cubic, but it was square centimeters. So sometimes I'll have a typo. I corrected it in class, but I didn't correct it on the electronic version. There's someone's hand over here, yeah.
Can you do the free response 3 on fall 21?
Sure. So fall 21, free response. Okay. This one? Oh, you said 3, not 2. This one right here? Okay. Yours is going to look a lot like this. It might be a velocity versus time graph, in which case I'd be asking for acceleration, but the process of getting the answer is still the same. The instantaneous velocity at t equal 1.75. That's right here. That means that I want to know the slope of this line. Right? It's a nice linear graph right there, so I can find the slope of that line. I do the rise. The rise is -1. The run, I'm going from 1 to 3, so the run is 2. So for part A, I would say that the velocity is rise over run. That's equal to -1 over 2, or -1/2 meters per second. And then I like it if you draw a circle or a square around your answer, please. And then what is the average velocity over the interval between t equal 3 and t equal 5 seconds? That's going to be between here and here. Effectively, here what you're doing is you're finding the slope of that line. Okay, it's not a tangent line. I'm just connecting those 2 points. Or I can think about it in terms of v average is equal to delta x over delta t, which is x final minus x initial divided by t final minus t initial. Recognize that's rise over run, right? X final minus x initial over t final minus t initial. So that's going to be x final is 0 minus 3, and 5 minus 3 here. This is in meters, this is in seconds, so that's -3 over 2 meters per second. You can leave it in fractional form. Or -0.5 and -1.5 would be okay too.
How do you get
-1 for the first one, for part A. Right here, the rise is going to be 3 minus 4. Right, to find the rise, it's x final minus x initial, and x final was 3 meters, and x initial was 4 meters. I start out at 4 meters, I wind out up at 3 meters. Okay? Okay, Jude? Good? All right. You will have a question like that. You're finding the slope, you're finding the average velocity or acceleration. What else, y'all? Specific questions? Yeah, go ahead.
Number 5 on fall 22. How is the answer not C?
This one right here, this sig
Yeah.
fig one?
Yeah.
All right, so the first thing, I follow my order of operations, which means I'm going to do this first. Because I have 2 sig figs there, I keep the lowest number of sig figs. That's just going to be 12. And then it's plus 3.6. Because 12 has no decimal places, then I just keep no decimal places. So the answer is going to be 16, because it was 15.6. So the answer is D. What did you think the answer was? C? Yeah. So
Or B. Not C.
B. Yeah, but you have to keep proper sig figs. So here I'll keep 2 sig figs, so I get 12. And then when I add numbers, I keep the lowest number of decimal places. Because I don't have any decimal places here, I keep 0 decimal places in the answer. When you're adding, multiplying or dividing, keep the lowest number of sig figs. When you're adding or subtracting, keep the lowest number of decimal places. You're going to have, I think, just one problem for sig figs. That's what I had on this one. So it'll be very similar to that, too.
16 on the same thing?
On the same one. Y'all stop me if I'm going too fast, all right? I want to get as much covered as we can. My wife and I were going on a double date tonight. We're going to the alumni grill. Chef, yeah.
What are you doing?
Alumni grill.
What are you going with?
It's Bob and Carol Eastwood. He's a pastor out in Shrevers. I know that's lame-o, like we're not gonna go out to the clubs or anything. We're probably home by 7. Which one am I doing? Who asked? Jude? Yeah. All right, so you're gonna have one like this, where I give you a velocity versus time, and you have to tell me the position versus time, or vice versa. I give you a position versus time, and you have to give me the velocity versus time. Remember that the value of this graph represents the slope of this graph. So right here, the value of this graph is small and negative. What I'm doing there is I'm just looking at the axis. I'm looking at this axis right here. So say, for example, this would be -1, -2, -3. And at this point on that graph, I'm still small, haven't gotten big yet, and I have a negative value. Not a negative slope. I know that line does have a negative slope, but I'm not looking at the slope, I'm looking at the value. So I have a small negative value. And then that small negative value describes the slope of the position versus time graph. So I want to look for a graph that has a negative slope. That, by the way, gets rid of that one and that one. Those both have positive slopes. That has a negative slope that is small. Notice this one has a big negative slope. This one has a small negative slope. So C is the right answer. All right, let's try a different one because, I can all sorts of ways to change this up. Don't try to memorize them. Instead, just understand, how to analyze these. Let's say that I have one that looks, I don't know, like this. So this is V versus T. Here I'm starting out with a small positive slope. So gosh, which answer would that be? Right. Yeah, A is the right answer. I'm sorry, does this bother y'all when I snap my fingers? Should do that in the exam, huh? Yeah, stretch out. I could just walk around and just snap like right in your ears.
That's sinister.
That would be mean, wouldn't it? I will show a clock tomorrow on the screen, but I used to make it the whole screen, and so it's like you had this constant tick, tick, tick. And so I'll make it smaller because you need to know what time it is. A lot of you don't wear watches, but you will have a clock tomorrow. Okay? Yeah, next question.
Number 19 on fall of 23.
Fall 23, number 19. Fall 23, 19. Okay, it's another one of these questions. These are hard. Yeah, like when I did it, you're gonna have one similar. When I did it on the video, I'm like, man, I think this is the hardest question on the exam. There's a lot of thought that goes into these questions. All right, so let's look at this. The speed. This first, recognize this is a position versus time. So the slope of this gives the velocity. The speed of the object at A and E is 0. That's true because the slope at those points is 0. That means it's come to a stop at those points. The acceleration at point A is negative. Well, look, at point A, that graph looks like this, the y versus t. This is my point A. I've just sort of blown up this section. I know that graph, right? That's the graph of an object that goes up and comes back down. So I know that has a negative acceleration. So I can go ahead and say out of hand that that's correct. But let's remember where that comes from. I have on one side a positive decreasing slope. It's positive and it's decreasing. It's getting less steep. That means that I have a positive velocity and it's slowing down. That means I have a negative acceleration. On this side, I have a negative increasing slope. It's negative and it's getting steeper. So that means that the acceleration is in the same direction as the velocity, which is negative because the slope is negative. So that's a negative acceleration. So the acceleration at point A is negative. If that confuses you, look, if you have a graph that has this sort of shape, that's negative acceleration. If you have a graph that has this sort of shape, that's a positive acceleration. I don't like people to memorize things, but sometimes people this confuses them. So if you just want to remember those two graphs, that's fine. The acceleration at point B is negative. Is that true? Which one of these is point B? Is it on this graph or this graph? It's this one, right. Like point B is this section of the plot. And so that means that at point B right here, it has a positive acceleration. For the same reason that I said before. Here I have a negative decreasing slope. That means I have a positive acceleration. Here I have a positive increasing slope. That means I also have a positive acceleration. So at points B and C, I have a positive acceleration. So that's not correct. And then the velocity at points C and D are negative. Point C and D, recognize that the slope here is positive and the slope also here is positive. So that is correct. So 1, 2, and 4. A is the right answer. Alrighty. So on some of the, hold on, Christian. So on second, Reese. So on some of those questions too, recognize that you're not looking at the slope, but you're looking at the value. So there are some other graphs where we're not showing position versus time, but we're showing velocity versus time, where the velocity graph might show something like that. And I might ask, when is the velocity positive and when is it negative? Recognize that when it's in this part, in this quadrant of the coordinate system, it has a positive velocity. And when the graph is in this part, it has a negative velocity. Because, you know, at the origin, this is v equals 0. I have positive in this direction and negative velocities in that direction. That's just reading numbers off of the graph. Practice those. Flip through the old exams and you'll see the different types of those. Reese?
Yeah, okay, so from point B on the graph, if it was higher, would it be the negative acceleration as well?
Yeah, so there is a point where you transition. So somewhere between here, it goes from being negative to positive acceleration. But when I did this, I put point B so that it was clearly close to this saddle point, this bottom part of this graph. So yeah, you're right. There is a point somewhere between here and here where it goes from having negative acceleration to positive acceleration. But it's definitely not point B. Like that's definitely positive because it's already starting to curve around. Somebody else had their hands up, Christian?
Can you do 18 on 1222?
Sure. 18 on 22. 18 fall 22. Okay, so this is a velocity versus time graph. Remember, the slope of a v versus t graph gives us the acceleration. The area gives us the distance traveled. So I want to know how far has it traveled in 5 seconds. The easiest way on this one is to split it into 3 pieces. There's a triangle, there is a rectangle, and then here is another triangle. So I can do that. I know that the area of a triangle, well, it's half of a square, right? So it's 1/2 of base times height. The base is 2 units. The height is 4 units, so it's 1/2 of 2 times 4. I got that, by the way, 0 to 4, that's where the 4 came from. 0 to 2, that's where the 2 came from. So that's equal to 4. That one has an area of 4. This one has an area of 2 times 4, which is equal to 8. I got the 2, it's going from 2 to 4, so 4 minus 2 is equal to 2. That's the base. And then the height is 0 to 4. That's the height. And then this final last one is 1/2 base times height. That's 1/2 of 1 times 4, which is equal to 2. So 4 plus 8 plus 2, that's 14 meters. I often have those questions. They're not on every exam, but they're on every other or so exam where I give you a v versus t graph and I have you find the distance. That's just finding the area. The big common mistake that students make is that they'll count up the squares, but beware that the squares often don't carry the same axis. I do that on purpose. So like here, on the y-axis, the square has a unit of 1, but on the x-axis, it has a unit of 0.5. So if you're just counting squares, each square would be 0.5 meters. So here I have 16 squares, 4 times 4, so it's 8 meters. Here I have, well, I have 8 squares, because it's halfway. Okay? So don't count the squares. Or if you do it, you know, in a clever way where you know the value for each individual square. A lot of this exam is about reading graphs. You know, it's not really about the physics so much as it is reading a graph and understanding a graph, which is a very important skill for y'all. Even if you're a biology major, like you need to know how to read a graph, any kind of measurement science. And unfortunately, a lot of students don't really get that until they get into graduate school or professional school. Okay? All right, what else? Yeah, enter. 4 from 23. Okay, you're going to have one like this. So you will have two dimensional analysis. One like the one, we did this one on the quiz, for the quiz last help session. But you'll have one like this too, I'm pretty sure. Yeah, you have one like this. The easiest way to approach this is just to solve it for the constant that you're looking for. So here I'm going to solve it for b. However you solve these things, I mean, I would say I would multiply both sides by x over a. However you learn that, the x's cancel, the a's cancel, and so b is equal to mx over a. And then put in the units for each variable. M is in kilograms, x is in meters. Be careful because x has the same, the unit name is the same as the variable for mass, so just be careful of that. Over meters per second squared, but I'm going to rewrite that like that, because when I bring that meters per second squared up, it flips it. The meters cancel, and I get kilogram second squared. C is the right answer. Yenta, is that okay? Or what? Okay. Yeah. But you will have one like that on the exam, as well as you'll have one like the preceding question, which we can do that if y'all want, or we can look at another one if you like, that we haven't worked. But, yeah, Tyrese? 19 on fall 19? Okay. Y'all been practicing the old exams? That's a good way to study. The students that do well, that's what they do. I expect several 100%, by the way. It's usually the case that I'll have at least a few perfect scores. So it's not an impossible exam. I just want to let y'all know it seems like it's difficult. I mean, it is difficult, but 19 you said, right, Tyrese? Okay. Yeah, so very likely to have a question like this. This was, let's see, fall 19. I get no out of free response, yeah. So you have a lot of graphing questions, qualitative, quantitative, like you're going to have, gosh, 8 questions probably, all told, that are just graphing questions like this. What is the object's acceleration at t equals 4.5? Recognize that this is a velocity versus time graph, and so the slope of this graph gives the acceleration. So I want to know the slope of this line. I do know that it's a negative slope just from looking at it. I can look at my options, but they're all negative, so that doesn't help me much. Then I find the rise. The rise is -3. The run is 2. So it's -3 over 2 or minus 1.5. Oops. Yep. See, I just did the thing that y'all do. Yeah, the run is actually 5 minus 4. So it's not minus 1.5, it's minus 3. Okay? Be careful. Don't be like me. But don't count the squares like I did. I know when you're in an exam, you feel rushed. Okay? Don't feel rushed. Just take a big, deep breath if you feel that way. And take a big, deep breath and just be careful in the things that you're doing. Are you going to write on the exam? Absolutely, lots. Like students that do well, they write a lot on the exam because it's easier to spot your mistakes when you write down things. If you do it in your calculator, you'll miss those mistakes often. Or if you're just thinking it through, think through on the paper. Write things on the paper. If you know exactly how to do everything, the exam only takes about 20 minutes. Now, it's not gonna, I don't think anybody will finish in 20 minutes because you have to think about things as you go through. So just pace yourself and be careful. Don't dawdle, but don't rush either. Yeah, Jude?
20 on fall 22.
20 on fall 22. Okay, so at point F, I want to know the object's velocity. On this one, you have to draw the tangent line. And you might draw a tangent line that's a little bit different from mine, but don't freak out if you do that. And if you find a slope that's not on there, you'll just find the one that's closest to what you find. So, but at point F, like the tangent line of this at this point is something like that. Okay? So to find that, I have a rise of minus 50. That's 50 minus, or 0 minus 50. And then a run of 1. So the slope is minus 50. You're not going to draw a tangent line that's anywhere close to minus 20, which is the next smallest number. Okay, you might find minus 40 or you might find minus 60, but you're not going to find something that's wildly different than that. But that's often what students do, is that they get a number that's a little bit different because they've estimated the tangent line a little bit differently than me, and so they sort of freak out when they don't find that exact number. Is that the problem, Jude?
Yeah.
Okay. Other questions? Yeah, Tyrese? Fall 1723. That's way back there, huh? '23?
Yeah.
Okay. This one? The runner velocity? That one right here? Yeah, you want to know how far this runner moves between 0 and 10 seconds? So you find the area under the graph to find distance from a v versus t. I find the area. So let's do this box right here first. It has a height from 0 to 12, so the area is 12 times 4 to 10, which is 6. So that's equal to, what, 72? And then here I have 1/2 base times height. That's 1/2 of 4 times 12. That's equal to 24. So it's 96 meters. That's pretty good in 10 seconds, right? Is that pretty good? For my runners. Avery, is that good? That's good. You can do that? 100 meters in 10 seconds? Okay, Yenta? Andrea? 100 meters in 10 seconds. No. Okay. Is 9 something the world record? Okay. Well, you can run it in 10 seconds, I'll give you extra credit. All right, Tyrese, does that answer your question? Find the area under the graph to find the distance. When you have a v versus t, find the area. All right, what else? Yeah.
On fall 23.
13 fall 23.
Is there like a formula somewhere to figure out the average speed?
Okay, we had a concept test like this. That's where this question came from. Sometimes I'll just go into those PowerPoints. They're on Canvas for chapters 1 and 2, and I just pick one. Like I'll just pick one. And so if you're looking for more stuff to practice, you can go through those. So here I have 4 miles at 60 miles an hour and 4 miles at 40 miles an hour, and I want to know the average speed. So if I average 60 and 40, the average of that is 50, right? 60 plus 40 is 100 divided by 2. If you remember this question, we had a couple questions like this when we did that concept test. We said that you're traveling for a longer amount of time at the slower speed. That means that your average is going to be skewed towards the slower speed. So it's not going to be 50, it's going to be below 50. You can go through and calculate the time required to do this distance and the time required for this distance, but it's easier to say, well, I'm traveling for a longer time at the slower speed, so my average is going to be less than 50. In contrast, there was another question where we said you travel 40 miles an hour for a minute or whatever, and then 60 miles an hour also for a minute, where you're traveling the same amount of time at both speeds, and in that case, the average was what? More than, equal to, or less than 50? Equal to. Right? When you're traveling the same amount of time, you just take the average of the two numbers. Might be a good idea to sort of skim through some of those concept test questions. You'll see that they're similar to a lot of the old test questions. If you're just bored, looking for something to do in the middle of the night, you wake up. Yep. Okay? What else, y'all? Tyrese? Fall 20? Fall 20. Fall 20 is a little odd because it was, isn't it fall 20? Was that COVID? Is that right? Yeah. So I don't think I had free. Is this at 17? Oh, that's 22. I didn't have free response that semester. And you'll also find that, oh, don't worry about 17. There was an error in that problem. Okay? Made an error in that. So just don't, can you just put a cross through it? Okay? Yeah. Okay? My advice here, get a good night's sleep tonight. Don't go out, don't go do stupid stuff like partying or whatever, like we're gonna do tonight. Y'all do that. Like, y'all just, you go home and you get some sleep, and don't stay up all night. So do much better for world. Okay? All right. Make sure a couple of you came in a few minutes late. Make sure I get your name.